Now we are ready to look into specific types of sequences, and we're going to study two types this semester. The first type is called arithmetic sequences, and the second is geometric sequences. And arithmetic sequences is where we're going to start today. So, an arithmetic sequence, for example, could be 4, 6, 8, 10, 12, etc. Okay? Another arithmetic sequence could be 1, 6, 11, 16, 21, etc. A third arithmetic sequence could be 20, 19, 18, 17, 16, etc. And here's one more for you. 2, -1, -4, -7, and so on. Okay? Now try to see a pattern in these different sequences. What are we doing each time in order to get the next number, right? And if you can see what we're doing and doing the same thing each time, hopefully, because I just made those numbers up real quick, then you'll know what an arithmetic sequence is. Okay? So hopefully you noticed in the first sequence that you added 2 to get 6, you added 2 again to get 8, you added 2 again, and you added 2, and so on. And so what we're doing each time is adding 2. In the second sequence, let's see, we went from 1 to 6, we were adding 5. If we add 5 again, we get 11. If we add 5 again, we get 16. And if we add 5 again, we get 21. So each time we are adding 5. Okay, so this one's a little bit different. It looks like we're doing 20 and then we get to 19. So we're actually subtracting 1 and subtracting 1 again and subtracting 1 again and subtracting 1 again. Okay. And then this one as well. It looks like we're subtracting something because we're going from 2 to -1. So that is a -3, right? -3. And then we would subtract 3 again. Subtract 3 again, etc. Oh, good. It looks like I picked all the right numbers. Okay. So, at this point, you should realize that what we're doing is repeatedly adding something to get the next number. And even when we are subtracting, you know that that would be adding a negative number, right? So you could still consider this adding. It's just adding a negative number. So these are all arithmetic sequences, and the goal of an arithmetic sequence is we're going to adding the same number every time. And that number that we add is called D. D is called the common difference. And I know we're adding, but then difference means subtracting. But it's because the way we get the common difference is we take the next term in the sequence and subtract the previous one. So in other words, 6 minus 4 is 2. 2 is the common difference. 8 minus 6 is 2. 2 is the common difference. In this one, 21 minus 16 is 5. 5 is the common difference. It works with negatives as well. 16 minus 17 is -1. -1 is the common difference. And -7 minus -4 is -7 plus 4. So that's -3 is the common difference. So if we want to write out the common difference for each of these, this would be D equals 2. D equals 5, D equals -1, and D equals -3. Okay, so the formulas for an arithmetic sequence are pretty simple and based on that. So first we have the recursive formula. I don't know if you remember what recursive meant, but it means based on the previous term. So we have to, for the recursive formula, we have to state what the first term is. A sub 1 equals what number? And then a sub n is equal to a sub n minus 1, that's that previous term, plus d, okay? And that's for n greater than or equal to 2. Because the first term really is where you're starting, and that could be anywhere. Notice I didn't start at 1 for all of these sequences, or 0, right? So, I started at 4. That was my choice where to start for each of these. So I have to define a sub 1, and then all the other terms are based on that previous term plus adding the common difference. So that is the recursive formula. And the explicit formula, an explicit means that it's a general formula that we can, as long as we know n, we can find a term. So the explicit formula is going to be a sub n is equal to a sub 1 plus d times n minus 1. Okay, now obviously we still need to know that first term because, that otherwise is not really defined by the rest of the sequence. But then we have its plus the common difference times the n minus 1. And so you don't need the previous term to use that formula. All you need is the first term and what the common difference is. Okay, so for example, we're going to just do one example here, and then I'll make another video with another example. Here is an example of a sequence: -6, -2, 2, 6, 10, etc. Okay, we're going to write explicit and recursive rules for this sequence, and we're going to make sure that this is arithmetic. Okay, and also we'll find the common difference if it is. All right, so it looks like from -6 to -2, I would probably, if I added 4, I would get from -6 to -2. If I added 4 again, I would get over here. Sometimes it's easier to see in the positive number, so you can always start anywhere in the sequence, but just compare it to all of the terms. So each time I am continually adding 4. So I know that d is equal to 4. Okay, I also right away know a sub 1, that's the first term, that's -6. Okay, so for a recursive formula, that's all I need to know. So I would state a sub 1 is equal to -6, and a sub n is equal to a sub n minus 1 plus 4. Okay? I don't plug anything else in because it's a formula. I need to know the previous term in order to find the next term. Okay? For the explicit formula, I also just need to know the same thing. So a sub n is equal to the first term, -6, plus 4 times n minus 1. Now, we can leave it this way. We've done this before. Or sometimes you'll see this is simplified a little bit. So in other words, we multiply that 4 through and then we combine like terms. So I like it this way. I have no problem with that answer. But sometimes we're going to see it more simplified. So that would be -6 plus 4n minus 4. So in other words, a sub n is equal to -10 plus 4n. So that's a simplified version of that formula.